Welcome back, children. So, in our last class, we have gone through the physical properties of matter and the characteristics of particles of matter. Today, we will do various states of matter. Now, if I ask you that how many states of matter are there, I think most of you will respond by saying that there are three states of matter: solid, liquid and gas. But in class 9, you will come to know that not only three, there are 5 states of matter. The first three, as you know already, solid, liquid and gas. The fourth state of matter is the plasma state. And the fifth state of matter is BEC, Bose-Einstein condensate. So, in states of matter, first is solid, as you already know. Second is liquid, this also you know. Third is gas. Fourth is plasma state, and fifth is BEC, that is Bose-Einstein condensate. So let us start with solid. Now in solid, you know that the intermolecular force of attraction between the particles is very great, is maximum amongst all the states of matter. And intermolecular space is negligible. For this reason, solids have a shape, definite volume, and they are rigid. Compressibility is not seen amongst solids. Diffusion between solid and solid is also very slow. Solids do not flow because the movement of particles is not there. So now if I say that when we keep sugar in a container, the sugar acquires the shape of the container. So can we say that sugar is solid? The answer is yes. Because if you consider each individual particle of sugar, it has a definite shape and size. Hence, sugar will be considered as a solid. Now, if you think of a rubber band, you say that a rubber band is capable of changing the shape. Again, yes. Whenever a force is exerted on a piece of rubber, the shape changes. But as soon as the forces are withdrawn, it returns back to its original shape. So, for this reason, a rubber band is also a solid. Then think of sponge. You say that solids are not compressible, but if you compress sponge, you can easily compress it. What is the reason? Then will sponge be considered as a solid? Yes, answer is yes. Now sponge gets compressed because of the tiny holes which are present in sponge, which are filled with air. When a force is exerted, then the air gets expelled from these holes. As a result, the particles move towards each other and it can be compressed. As soon as you remove the force, the sponge returns to its original shape and size. So, we can say that yes, a sponge is a solid. Now let us come to liquids. Liquids don't have a definite shape, but definitely it has a definite volume. In liquids, the intermolecular force of attraction between particles is less than solids but more than liquids. In liquids, the intermolecular space is also more than solids but less than gas. A liquid can acquire the shape of the container in which it is kept. A liquid can also flow, so it has fluidity. And liquids can also diffuse into another liquid faster than solids but slower than gas. So when it comes to the diffusion, now you can say that gases can diffuse into liquids easily. For example, oxygen, carbon dioxide, all these can easily enter a liquid body, diffuse into a liquid body, say water, from the atmosphere. And it is these gases which are present in water which makes aquatic life possible. Aquatic life survives due to the presence of oxygen and carbon dioxide in water. So, liquids have greater rate of diffusion than solids but less than that of gas. Now, if you come to gas, what about intermolecular force of attraction? In gases, the intermolecular force of attraction is negligible. What about intermolecular space? In gases, the intermolecular space is maximum. For this reason, the molecules can move about each other randomly, rapidly, with great energy. They collide with each other and they move in all possible direction. It is highly compressible since the particles move about randomly with great speed and gases can acquire large volumes. By applying pressure, these particles, these molecules can be brought close to each other. For this reason, it is possible to compress gas and transfer it in the form of liquid and keep in cylinder. I am sure what I am speaking of, you can understand. I am speaking of LPG and CNG. The liquefied petroleum gas which you use at home, which comes in your home in the form of cylinders, gas cylinders. There, LPG is compressed and made to acquire a very small volume within the cylinder. Same thing is CNG, compressed natural gas, which is being now used in a lot of vehicles. That is also compressed into small cylinders and it is used as a fuel. So, gases can be compressed. Gases are highly compressed. Gas also do not have any shape of their own. They don't have any size. They don't have a definite volume. So, now you must have experienced that whatever your mother cooks in the kitchen, you can easily get the smell of the food. Why is it so? That is because the aroma of food mingles with the particles of air. That means the aroma of food particles diffuses through air very quickly and reaches you. Clear? So, rate of diffusion in case of gases is maximum. Clear? Now, when gas is kept inside a container, I told you, because particles have great energy, they are always mingling with each other, they are colliding with each other. At the same time, they are also colliding with the walls of the container. As a result of which, this force with which the gas particles collide per unit area of the walls of the container causes pressure, and this is why gases kept in a container exert pressure on the walls of the container. Clear, children? So, I think you can easily differentiate between solids, liquids and gas. Easily you can write down 5-6 points. So please try to write at least 6 points of difference which I have mentioned in your rough copy. So 6 differences you must write between solid, liquid and gas. In our next class, since these 3 forms of matter has been explained, in our next class I will deal with plasma state and BEC. Thank you. Please like the video and share it with your friends. Thank you.